it will be a recorded session. So those who are absent now, maybe they will be getting some ideas after exploring the lecture. So in my region, actually the network connectivity. Walaikum assalam. Yes, please.
Sir, my network is getting up and down a little, sir. So, sir, I'm getting kicked out of the meeting, sir. So, sir, I will join, sir, every time, sir.
No worries. So in whole Dhaka city, we are facing the same problem. I may also face some problem, but hopefully we'll be continuing fine. So I will not switch on the camera as it takes more bandwidth. So just voice communication, I think it will be okay for you. So let me start, formally. Bismillahirrahmanirrahim. Dear beloved students, Assalamu alaikum wa rahmatullah. I welcome you all to this online session. And I know many of you are facing a problem of internet bandwidth due to the, disruption in the IIG of Mahakali. So since it will be a recorded session, so you may download the record and you can explore further. Since you all are together, so I need to explain some of the problems in distant vector routing. In the last class, in one section I have started, but I could not finish. In other section, I discussed. So let me explore the problem in distance vector routing. It is basically the instability. So we were exploring different types of routing, and we explored the distance vector routing. Now we are exploring the problem in distance vector routing. First one is the two-node instability. What is meant by instability? It means that the network is not in a stable situation, or the network is in a vulnerable situation. You see the figure shown in the slide. Figures shown in the slide, you see before prelude. So this is the network diagram. Before failure, you see the distance from the node X to node A. It is 5 units. It's 2 units. Okay. And distance from A to B, it is 4 units. But what happens? Link between X and A is disconnected or cut down. It means there is a failure. Since A is not getting any feedback from A, so the routing entry in A for X will be simply infinite. Well, now you see, this is the after failure case, but after A receives updates from B. So X is disconnected now, but suddenly node A receives update from node B. So you see, now after A receives some update from B, you see that 6 become 10. Why? Because A records that to reach A, you see, it requires 6 units. Now you see, after A receives update from B, it becomes 10. Why 10? Because the distance between A and B is 4 units. Well, how long it will continue? When B receives update from A, B accordingly update the matrix from 10 to 14 because it has added 4 units. If it continues, you see the reachability will be in fact infinite. So it means that in such situation we experience, or the network experiences, two-node instability. So besides two-node instability, we have three-node instability also, but there are some solutions for two-node instability. What are those solutions? One is actually defining infinite. So after long loop, a value might be infinite. But sometimes we can also redefine the value of infinity. That means we can redefine after how long the value will be infinite. So this is the defining infinity or redefining the infinite. This is the simple solution. Sometimes it happens that the size of the network cannot exceed 15 hops. So if it exceeds 15 hops, the distance might be infinite. Okay, so defining infinity is a simple solution. Then split horizon. The network is splitted into some horizon. So in this strategy, instead of flooding the table by each interface, each node sends only part of its table through the interface. Now the network is splitted. We call the split horizon. That means we are dividing the horizon into multiple range. So split horizon still has some drawbacks. For this reason, the node use some sort of timer So what is the benefit of timer? You see, why not be in the scenario eliminates the route to X from advertisement to A. Node A may guess that this is due to the split horizon strategy, or because B has not received any news about X recently. The split horizon strategy, it can be combined with the Poisson's reverse strategy. What is happening in Poisson's reverse strategy? Here, node B can still advertise the value for X, but it is the source from where it gets the information. The source is from A. So if it advertise information to A, where B has got the information from A itself, then it is not allowed. So rather than updating, it will simply make the length as infinite, so that it can never accept. So this is actually the split horizon with Poisson reverse. So the two-node instability problem can be solved by three different ways: defining the infinity, split horizon, and Poisson reverse. Now you see the distance vector routing might also face three-node instability. So in three-node instability, you see, instead of X, A, and B, we have another node called C. So node ABC. Here they can exchange information. You see, when the distance between X and A you see 2, then 6, and for C it is 5, because 2 plus 3 is 5. But what happens? A sends the route B and C. Sends route information to B and C, but suddenly the packet to C is lost. What will happen? You see, B sends the route to A. And you see, C sends route to B. So this situation may create the three-node instability. So these are the types of instability that might occur in distance vector routing. So in the text, the solution for two nodes are given, but solution for three-node instability is not available in the text. So we'll just explore what is meant by three node instability, and it is actually the instability problem for the distance vector routing. I see this is an example of the routing information protocol that is working with the distance vector routing. Now we'll explore the link state routing. There are some basic difference between distance vector routing and the link state routing. Distance vector routing was solely dependent on the distance among two different nodes or two different routers. But link state routing, it is a little bit different. Here you see every node has the entire topology of the domain. So instead of dealing with the distance in link state routing, each node has the entire topology of the domain. What is meant by entire topology? It means that it contains the list of nodes and links, their connection type, their cost, and also the condition of the link, whether the link is up or link is down. So here the node can use some algorithms. For example, the Dijkstra's algorithm. So in link state routing, the node can use the Dijkstra's algorithm and it might develop its own routing table. The best example of link state routing is the explanation of CityMap. We don't have, you see, CityMap in Dhaka city, but if you travel to different other cities, you can see the city map or the subway map. That subway map is actually depicting the whole picture from where you can go where, and you can also explore which way you should follow and which way you should not. So see the concept of link state routing. The basic thing is each node contains the topology of the network. So how it works, you see, we have multiple nodes from A to E. Have the state of links, these states of links, and so on. Now you see the Dijkstra's algorithm is following pseudocode. So you see the routing table for a particular node, the cost, and the next route. Now you see in Dijkstra's algorithm, it starts is finally it's some starting point, and it's, you see, take the local node as root node, or it sets the root node for a particular local node. That means this node is root node. And after selecting the root, it moves to its tentative list. So there is one permanent list and there is one tentative list. Okay, then you see so first of all, after setting the root to a local node, now it moves towards the tentative list. Initially, tentative list is empty.
Sir,
Yes, please.
sir, আপনি যে কিছু লিখছেন দেখা যাচ্ছে না।
The slide is not visible to you.
তো স্লাইড ভিজিবল স্যার, কিন্তু স্যার মানে আমি যে ভিডিও বেস করতে পারছি না এটা। তাহলে স্যার একটু গ্রাফ দিয়ে বোঝালে ভালো হতো আর এটা।
Which one?
তুমি ডাইজেস্ট অ্যালগরিদমটা স্যার একটু এক্সাম্পল দিয়ে বোঝালে ভালো হতো।
We have a particular example. Just let's see the flowchart first. Then you will see the example. So here we simply set root, local node. We set type of list. One is the tentative list, which is initially empty. So the tentative list is empty. We simply stop. The algorithm simply stops. It is known that the list is not empty. What will happen among the nodes in the list? Move the one with the shortest path permanent list. So you see, add each unprocessed neighbor of last move node to the tentative list. Already it is not there. If neighbor is in the tentative list with larger cumulative cost, replaced with a new one. So this is a simple algorithm. Now we will explore the Dijkstra's algorithm with a particular example. You see here, this is the topology. We have 5 different nodes. See here. First of all, set the node A, the root node, and you see into the tentative list. So we have set a particular local node A as root, and we move node A or root tentative list. Then after exploring root A, you see move A to permanent list and add B, C. That means the directly connected node to root A. You will have to add the directly connected node, for example, This node is root node. So when we move the root node A permanent list, we will add directly connected node B, C, and the tentative list. Now you see, based on the costing, since the Dijkstra's algorithm works on the shortest path, so you see, third stage move C to permanent. Why we will move the node C to permanent list? Because its distance is only 2. This one to explore first. Okay, so move C to permanent and add it to tentative list. Because we are adding C permanent list, so the node connected to C, it should be in the tentative list. In the same way, you see, the next one node export is B. Why is B? Because of its shortest path. So we are moving node B to permanent list, and it doesn't have any link connected, so we now explore node B permanent list. So node C, B, D is in the permanent list. Now it will explore tentative list content E, and you see move E to permanent list. Now tentative list entry becomes empty. So since the tentative list is empty, it's true or yes, the algorithm will simply stop. So this is the very simple explanation and the working principle of Dijkstra's algorithm. Do you have any questions or confusion here?
No, sir.
Well, so let's proceed then. Now you see, we have a concept of autonomous system in the open shortest path first. So we define here three different area. Area 1, area 2, and also the area 0. So the whole different area, these are connected by three different area route, or we can say the border route, and as a whole it is regarded as the autonomous system. So one autonomous system might be connected to another autonomous system and can use the principle of open shortest path first. This is another routing technique among different autonomous systems. So we simply call it is OSPF, or the open shortest path first. Now, in this routing, we have three different types of, or four different types of links. One is point-point link, another is transient link, the stop link, and the virtual link. So what is actually the point-to-point links? A point-to-point link, it connects two different routers without any other host or router in between or connecting to the link. So only two different routers are connected to a particular link. We call the point-to-point link in a point-to-point network. We have also the transient link. By transient link, actually it means a network with several routers that might be attached to a particular transient link. You see, Ethernet network, for a transient link, we might have different routers. So transient link basically represents different routers are connected in a particular link. Now you see concept of stub link. So in stub link, a network that is connected to only one router. So the stub link means a network where it is connected to only one router. And you see, in the OSPF, we might have different type of connectivity. So in terms of, you see, you have linkage, for example, T1 line or 3 line. Perhaps you have the idea that we have E1, E, and T. There are two different types of communication link that is normally used in the wide area networking. So these are the two different standards where the multiple link and the router can be connected. So here you see in the OSPF routing, we have actually a path-width routing where routing field is actually representing destination and the corresponding path through a particular autonomous system. So you see here is the autonomous system 1, see as different destinations from 1 to A5, multiple interfaces. You see, this particular router it receives the packet from source S1 and it transmits through only one interface. But this interface is not transmitting. This is the concept of unicast. So this router receives, it transmits through a particular interface, and finally this sync towards the destination. So this is the concept of the unicast routing protocol. Now in multicast routing, the router may forward the received packet through several of its interfaces. But how it is transmitted? See, the source, the same thing here. Source is transmitting the packet, but it is, you see, router is transmitting multiple interfaces. So this is actually the concept of multicast, but unicast means the router will forward the packet through a single interface. So this is basically the overall discussion in the routing protocol. In short, we have explained the distance vector routing, for example, RIP, information protocol. We have explored the concept of linked state routing in terms of the Decas algorithm or the shortest path algorithm, and we have also seen the open shortest path first protocol. And by using the open shortest path first protocol, different autonomous system can communicate. And we have also seen different types of link that are used in the routing protocols. And finally, we have seen the multicast routing protocols. And in this topic, we have explored the concept of unicast, multicast, and also the application of multicasting as the video communication or video-based multicasting. So with this, I want to conclude the discussion for the network layer. Now I will proceed towards the transport layer. So maybe after a 5 minutes break, we'll be starting for the transport layer protocol. Is it fine for you?
Yes, sir.
Yes, sir.
Okay, just have it, cup of tea by 5 to 7 minutes maximum. Further?
Yes, sir.
Oh, fine. So please notify me if it is the Maghrib time. Then we'll take some break for the prayers. Beloved students, so we have finished the routing protocol basics. Now we are switching towards the network layer, TCP layer or the transport layer. The transport layer, it's the companion layer for the networking layers. So the network layer actually works for end-to-end delivery, but the transport layer works for process-to-process delivery. That's the main point of difference. One is end-to-end, another is process-to-process. That's why you see the chapter topic is process-to-process delivery. But to deliver from process to process, what are the different protocols? In this chapter, we will be exploring 4 different transport layer protocols. One is the UDP, that is user datagram protocol. One is the transport layer, transport control protocol. Is SCTP, the session control transmission protocol, and there is a newly added protocol which is called the quick protocol. So in transport layer, we'll be exploring 4 different protocols: the user datagram protocol, transmission control protocol, SCTP protocol, and the quick protocol. Well, let us proceed further. transport layer is responsible for process-to-process delivery. The transport layer is responsible for process-to-process delivery. The delivery of a packet, part of a message from one process to another. Two processes communicate in a client-server relationship. So these are a very basic thing of the transport layer. The first one is the process-to-process delivery, then delivery of a packet, and two processes communicates in two different computers. One is client, another is server. You see, what is actually meant by process-to-process delivery? This is simple network where we have two different computers, and you see the internet. It consists of multiple routers. So you see there are different types of communications. One is node-to-node communications, another is host-to-host communication, another is process-to-process communication. Three different types of communication. Communications are performed in three different layers. Node-to-node communication, sometimes we call link-to-link communication. It is performed in data link layer. Host-to-host communication or end-to-end communication is called is happened in the network layer. And process-to-process communication, it happens in the transport layer. So this figure is actually representing three different types of communication. But if I ask you when this sort of communications are carried out, this is the important point. If you communicate within your network or within the LAN, this type of communication is node-to-node communication or link-to-link communication. That is, you are in the same link of the network. If two different computers over the internet communicates, it is basically the node-to-node communication. For example, you are sending some sort of ping command. Ping means from one host to another host. This is host to host. And the last one is process to process. What is meant by process to process? For example, I am using the Zoom applications. You are also using the Zoom applications. So we are communicating with each other. Definitely, it is an example of process to process communication, because Zoom in my computer is a process. Zoom in your computer is working as a process. So process to process communication, it is performed with the help of the transport layer. Now you see, if you want to perform process to process communication, at that time we need another type of addressing. In the first chapter, perhaps you remember that we have four different types of addressing. One is the physical addressing, logical addressing, port addressing, and the addressing by URL. Okay, so in this figure, you see port numbers are given. That means for carrying out process-to-process communication, we need basically the port number also. You see here, in a particular computer, there is a daytime client. Let me say client showing the daytime. And in the server, there is a process called daytime server. Okay, the client in client computer daytime process is identified by 52,000, and in server the daytime process is identified by 13. This 13 and 52,000 are two different ports, and port basically work in the transport layer. So you are transmitting some data from the daytime client. You see the data. You see the data, and it's going towards port number 13, and it is coming from port number 52,000, and it's also sending the data. So it is carried out with the help of the port addressing. Now you see IP address versus port number. This slide is also quite important for your understanding. You see here, the port number, select the process, IP address, select the host. Now, as the IP address is maintained by the APNIC or Internet, so the port number is also maintained by IANA. So IANA defines the ranges of ports. So what is IANA? Can any of you recall from the chapter 1? In the chapter 1, perhaps we have explained the organization name of different. Do you remember IANA?
No, sir.
None of you?
আচ্ছা আবার বললে ভালো হয়।
This is the range. The range is defined by IANA. IANA is basically Internet Assigned Named Authority. Internet Assigned Named Authority. So the port address is not open for all the time. It has also some regulatory body. There's the IANA, Internet Assigned Named Authority. So you see, it starts from 0 to 65,535. Why it is so? Why it is from 0 to 65,535? Can any of you answer? Any of you answer this question? Okay, the simple answer is actually it is nothing but to the power 16. It is to the power 16. Is equal this value 65,535. So this 65,535, this range is divided in different types. You see, from 0 to 102, these are the well-known port. And from 104 to 49,151 is the registered port. So if you want to use this port, you will have to register. And register to what? Register to IANA. And remaining ports are dynamic. That means, so these are the ranges of the ports assigned by the internet assigned named authority. And this is the concept of socket. Socket is basically the concatenation of IP address and port number. So the IP address as well as the port number together we call the socket. So by socket, actually we can communicate to a particular process. We can communicate to a particular process. You see, it is a very interesting concept, the concept of multiplexing and demultiplexing. Okay, one thing, this is the Maghrib time. So what we can do today? Should we continue further or should we stop here?
So stop here.
Okay, so after Maghrib prayer, do you have any other, engagement? As I came to know you have some other program.
স্যার আজকে ছেড়ে দিলে ভালো হয় স্যার, এমনি অনেক দেরি হয়ে গেছে।
Okay. So I think it's fine. So let me, end today here. Inshallah, in the next class. When is your midterm exam starting?
Sir, our midterm exam was supposed to be held today, sir. Sir, আজকে networking midterm ছিল, sir, but অবরোধের জন্য হচ্ছে স্যার পিছিয়ে গেছে, স্যার।
Okay, so it might be in the next class.
স্যার রবিবারে আপাতত বলা হয়েছে যে রবিবারে হবে, স্যার।
Okay, fine.
যদি স্যার অবরোধ না হয়, স্যার। জি স্যার।
Okay, so let's conclude here. Inshallah, in the next class we'll be continuing with the remaining some topics of the TCP protocol. Fine. Thanks for your kind cooperation. Actually, this morning I have some, emergency engagement. That's why I'm bound to shift the class, and you have wholeheartedly participated classes, and your positive gesture is really praiseworthy. So now I am concluding. Assalamu alaikum wa rahmatullah. And before leaving the class, you please just send the message mentioning your name and ID. So it will be recorded, and I'll be getting the record from the chat information, and accordingly you will get the attendance. Fine. Thank you once again.
আসসালামু আলাইকুম স্যার।
Assalamualaikum, sir.
Walaikum assalam.